modern way of living continuously increases the energy demand in an unpredictable way, requiring an increase of generation capacity as a result. In addition, the electricity network faces the high penetration of renewable energy sources, which has a considerably negative impact on the overall grid stability. Such excessive energy demand, along with the intermittent nature of generation coming from the sun and the wind, brings critical challenges to the grid operation, requiring costly investments in infrastructure, with higher energy prices following shortly thereafter. The solution to the problem could be changing the perspective. Instead of focusing on the supply, it's time to take charge of the demand. Demand-side management has the unleashed capacity to overcome some of the major barriers of controlling and balancing supply and become a powerful tool at the hands of grid operators. Nevertheless, today a very limited share of demand-side management is actually integrated in the markets, and it only applies to large industrial and commercial consumers who have the capacity to participate in the programs that currently exist. The INERTIA framework relies upon the intelligent aggregation of both demand and generation at building level, offering demand-side management on significantly higher level than those of single individual load appliances. All assets at local control hub environments are handled as active elements, allowing energy performance optimization strategies to be performed at building level, and further leading to more energy-efficient clusters of prosumers that actively contribute to the overall grid performance. The three main drivers at local building level are occupancy monitoring and prediction, user profiling, and demand flexibility. By keeping a balance between energy, comfort, and business criteria, a holistic flexibility management framework is established, allowing the optimal building operation in real time, following grid's conditions and needs. A number of tools have been developed by the INERTIA project to facilitate the realization of the demand-side management strategies at building level. Building facility managers are equipped with powerful tools for real-time monitoring and control of their building's assets, while a series of end-user applications have been developed to address the awareness of the participating building occupants. In addition, the INERTIA framework provides services and tools to aggregators and distribution service operators, allowing optimal monitoring and management of their portfolio under different grid conditions. The INERTIA framework is deployed and thoroughly tested in 3 different pilot sites in 3 European countries, combining real working environments, renewable generation and distribution service operations through the simulation of a microgrid environment. CERT premises in Greece embody the real and prosumer pilot, including a set of multifaceted areas hosting 5 institutes covering a wide variety of research domains. IT building hosts most of the INERTIA pilot areas, featuring a number of offices along with connecting corridors, meeting and rest areas. The offices range from small 2 to 3 people offices to bigger ones that can host up to 10 people, while the rest of the utility spaces present more obscure numbers with more diverse occupancy flows. The kitchen area is further equipped with the Indesit small dishwasher delivered within the project's context. A conference room in the nearby INA building is further utilized to experiment with systems scheduling capabilities. Addressing storage units as a load of interest in the project, HIT premises possess different electric vehicles that are exploited for the scope of the INERTIA as storage units. In addition, the standalone power system available at CPERI premises, comprising of a solar 10 kilowatt photovoltaic array equipped with a lead-acid accumulator along with fuel cell generators available, further facilitated the exploitation of renewable energy resources in the INERTIA framework. The multi-sensorial network deployed at CERT pilot areas allows for the real-time occupancy extraction, along with real-time monitoring and automated control of various types of devices and appliances, aiming to reveal the amount of available flexibility of a real prosumer based on everyday building operation and real occupants' needs. The microgrid laboratory of Tecnalia in Spain set the second demonstration site of the project through the simulation of grid operation. In addition, 2 diesel generators combined with an advanced control system are integrated in the platform to further evaluate the impact of local distributed generation. Finally, The Swedish pilot is established to collect and manage generation data from local solar, PV and wind generation sites. Furthermore, a charging station is integrated in the system, providing a monitoring framework to further examine the impact of mass penetration of electric vehicles in Europe.